Okay, picking up on example 6. Find the zeros of a polynomial function with complex zeros. So it's find the zeros of the polynomial. All right, well, I'm going to do what we've been doing so far. Find my constant, which is 3. My factors of 3 are plus or minus 1 and plus or minus 3. My coefficient of my leading term is, make sure they're in order, is 3. Oh, sweet. Factors of 3 again. Plus or minus 1, plus or minus 3. All right, so our possible rational zeros. Pardon me. Are plus or minus 1 over plus or minus 1, which is plus or minus 1. Plus or minus 1 over plus or minus 3, plus or minus 1/3. Plus or minus 3 over plus or minus 1 is plus or minus 3. And plus or minus 3 over plus or minus 3 is plus or minus 1, which is right here. So I'm not going to repeat that. All right. So now I'm going to use synthetic division. Okay. We can start with the 1. So let's do that. Let me pull up an extra sheet of paper here. I want to give myself space. I don't know which one's going to work. So I'm just going to do my best to figure it out. So let's start with 1. That's always nice. We'll do the fraction last if we have to. So starting with 1, we've got 3, 9, 1, and 3. All of them are represented, so we're good to go. Bring down my 3. 1 times 3 is 3. 9 plus 3 is, I'm losing my mind, 12. 1 plus 12, I'm sorry, 1 times 12 is 12. Plus 1 is 13. Times 1 is 13. Plus 3 is 16. So this is not, 1 is not a factor. Let's plug in -1, see if it is. So bring 3, 9, 1, and 3. Bring down your 3. Times -1 is -3. Plus 9 is 6. Times -1 is -6. Plus 1 is 5. -5. And times -1 is 5. That's 8. That is not either. So let's try positive 3. 3, 9, 1, 3. Bring down your 3. 3 times 3 is 9. 9 and 9 is 18. 18 times 3 is 18 times 3, 54. Plus 1 is 55. 55 times 3. This is not going to work. 165. Plus 3 is 168. This is not going to work. All right, let's hoping for -3 so you can avoid the fractions. Woot, woot. 3, 9, 1, and 3. Bring down your 3. -3 and 3 is -9. Ooh, that's 0. Times -3 is 0. 1 times -3. Sweet. There is our winner chicken dinner. So -3 is a 0. Okay. What are we doing here? I don't even remember anymore. Find the zeros. So -3 is a 0. I'm going to come back up here now. So x equals -3. It's one of my answers. And now I can just take, I need to come back up here and grab that paper. I need the 3, the 0, and the 1. So 3, it's not x cubed anymore, it's x squared. We have 0x and then plus 1. So plus 1. I need to set this equal to 0 and factor. I'm going to do this by the square root property. So subtracting 1 from both sides. 3x squared is equal to -1. It wouldn't have factored nicely otherwise. Divide both sides by 3. And x squared equals -1/3. Take the square root of both sides, plus or minus on the right. So we have plus or minus the square root of -1 over the square root of 3, which is plus or minus the square root of -1 is I over the square root of 3. So those are my other 2 zeros. I over the square root of 3 and negative I over the square root of 3. And we needed 3 zeros and we got them. All right. There's the complex version. Okay. New rule. Complex conjugate theorem. If a polynomial function has real coefficients, there's not imaginary coefficients in front of your x squared or your x cubed or anything. They have to be real numbers. And a complex zero in the form a plus bi. So one of our zeros is a plus bi. Then its conjugate, the complex conjugate, then the complex conjugate is also a zero, as in this case. I over the square root of 3 is a zero, as is its conjugate, which is just the negative version of I over square root of 3. So the complex numbers have not gone away. We're just using them to keep developing your algebra skills, okay? So if you weren't comfortable with complex conjugates before, please go back and make sure that you're comfortable with them coming into here, okay? All it is it changes the sign of the imaginary part of the a plus bi. So if it is a plus bi for your complex number, then it's this is your complex number. Then its conjugate, complex conjugate, you don't need to write this unless you don't know it, is a minus bi. It just changes the sign of your imaginary part. Now you're not going to need to do that unless it doesn't pop up as a zero. So I think this one's going to do that for us. Using the linear factorization theorem, to find a polynomial with given zeros. Find a 4th degree polynomial with real coefficients, no imaginary ones, that have zeros of -3, 2, and I, such that f of -2 is equal to 100. So when we do this, we're going to set up a polynomial because we're looking for a polynomial. And of course, we need an a because we don't know what it is. Now, for each one of these, you need to take and understand that this is x is equal to each of these. So I want to come back up here. I need separate paper. So if x is equal to -3, x is equal to 2, and x is equal to I, you need to set each of these equal to 0 to find out what we're going to plug in for our binomials. We're going to need 4 because we know we have a 4th degree polynomial. All right, so it's going to be this one. We're going to add 3 to both sides to set it equal to 0. This one we're going to subtract 2 from both sides to set it equal to 0. And this one will subtract -I from both sides to set it to 0. So remember, because if a polynomial function has real coefficients and a complex 0, then the complex conjugate is also a 0. So let's plug these in and I'll show you what I'm talking about. So we're missing one, and that's because we're missing our complex conjugate. So if x equals I, x also equals -I, the complex conjugate. So we need to add I to both sides. So x plus I is equal to 0. All right. This is our complex conjugate. Now they didn't list it in our zeros, but we knew we could use it because of this theorem. Somebody did the work for us. All right. First thing I want to do is simplify this. I want to multiply all this out so I can take the next step. All right, I'm going to multiply these two first, these two binomials, which is x squared, outer is -2, inner is +3. So that's going to be positive x minus 6. Well, I'm going to multiply these two, x squared minus I plus I minus, so this is going to be -I times I, which is minus I squared, and I squared is -1. So this becomes +1. Okay. Bring this down. And I need to multiply these two. I need space. So x squared times all this, x to the fourth, x cubed, 6x squared, and then 1 times all of it. Combining like terms. All right, there's my completely simplified. Plus x cubed minus 5x squared plus x minus 6. All right, now that's as simplified as I can get it for now. I've combined everything, I've multiplied everything, and I need to find my a to finish this out. And remember, this is f of x is equal to y or equal to f of x. So I'm going to let 100 be my f of x. And every x I'm going to let be -2. All right, let's simplify. So let me use paper again. -2 to the fourth is going to be 16. It's 4 times 4, yep, 16. And then this is going to be -8 minus 5 times 4. And then -2 minus 6. This is 16 minus 8 minus 20 minus 2 minus 6. Let's just throw that in the calculator and see what we get. 16 minus 8 minus 20 minus 2 minus 6. And I got -20. So this is times -20. Dividing both sides by -20. A is equal to -5. Okay, so let's write our polynomial. We can write up here. F of x is equal to -5, and then I'm just going to bring all of this down. Finally, I'm going to I'm going to distribute that -5 over all this just to have a really nice, sweet polynomial that's done. It's just math when you can. Minus 5x cubed plus 25x squared minus 5x plus 30. There is my polynomial. That was some stuff, y'all. All right. Descartes' rule of sign. So the number of positive real zeros is either equal to the number of sign changes of f of x or is less than the number of sign changes by an even integer. Okay, so here we've got positive going to a positive, positive going to a positive, no sign changes yet, positive going to a positive, no sign changes, and then we have a positive going to a negative. Now you can only do this if they are in order and everyone's represented. Okay, the number of negative real zeros is either equal to the number of sign changes of f of -x or is less than the number of sign changes by an even integer. So in this case, they plug in -x for each of these x's. Then they simplified. This is what they get when they simplified. Now we're going to look for the sign changes. This one's going from positive to negative, so there's 1. Negative to positive, there's 1. Positive to negative, there's 1. And then negative to negative. So this has 3. All right. So let's use that for this last question, this last example, and using Descartes' rule of signs to determine the possible number of positive and negative real zeros for the function f of x. All right, so the first thing we need to do is look at what we already have. Okay. Do we have any sign changes now? I'm going to write this a little bit bigger so it's easier for me to see. It's negative x to the fourth minus 3x cubed plus 6x squared minus 4x minus 12. Okay. 4, 3, 2, 1. They're all represented. Negative to negative, no changes. Negative to positive, there's a change. Positive to negative, there's a change. And then negative to negative, so 2. So if there's 2 sign changes, this is equal to 2 or 0 positive real roots. Now, where did I get that 0? Back here, it says equal to the number of sign changes, which would be 2, or is less than the number of sign changes by an even integer. Well, 2 minus 2 is 0. So that's the answer for our positive. Let's substitute negative x for x. I'm going to take all of these, f, and make it f of negative x. So negative x to the fourth minus 3 negative x cubed plus 6 times negative x minus 4 times negative x minus 12. Now we have to simplify before we do anything further. Please don't try to skip steps. It doesn't work. Negative x to the fourth, because this becomes positive times the negative is negative, minus 3 times negative x cubed minus 6x plus 4x minus 12 is negative x to the fourth minus, plus 3x cubed minus 6x, squared. Forgot the square. So I messed that up. Hold on, y'all. I didn't put the square on here. So negative x squared is positive x squared. So this should be a positive. Ooh, glad I caught that. Plus 6x squared plus 4x minus 12. All right, that's simplified. Now we've got negative to a positive. There's 1. Positive to positive, positive to positive. And then positive to negative. There's another one. Again, 2 sign changes. So that means we can have 2 or 0 negative real roots. That's it. That was a tough 5.5. Any questions? It's going to take lots of practice, y'all. I understand that 100%. Let me know what I can do to support you. You're just going to have to put in the practice. I'm here.